Here's one more example using the product and quotient rule. This example actually uses both the product and the quotient rule in the same problem, which is kind of interesting. You may be able to see that, especially if you're pretty good at this stuff. You could probably see that we'll have to use the quotient rule on here because we have something divided by something else. But then you might also notice that up top here we have something times something else. So the way this will all play out is to first think about this as a quotient rule problem. So we'll call the top, the numerator, f1 is x times e to the x. And as always, we'll need to find that derivative. And then g1 is what we'll call our denominator here, 1 plus x. And fortunately for us, g1 prime is a derivative we already know. In this case, it's just 1. So really, if we could figure out what goes here, what is f1 prime, we'd be in good shape, right? We don't just have to plug in all these pieces into the quotient rule and we'd be done. Unfortunately, it's not immediately apparent what f1 prime is. You might remember it. I think this was the same function we tackled in the product rule video. But in case you don't, the way to think about it is think about it like it's a whole new problem. Think about it like you're trying to take the derivative of x e to the x. Right? We're trying to figure out what the derivative of this function right here is. And the way we'll do that is by using the product rule. We have the first function, maybe I'll call it f2 now just to keep it separate from this f. f2 would just be x. f2 prime is the derivative of x, which is just 1. g2 is our e to the x, and g2 prime is also e to the x. So putting these pieces all together into the product rule, we can figure out what the derivative of x times e to the x is. See, the derivative of something times something is the derivative of the first thing, f prime, just 1, times the second thing, e to the x, plus the derivative of the second thing, e to the x, times the first thing, which, as we did before, we can simplify to this. Both this and this are equivalent, and they're both what the derivative of x e to the x is. So, kind of to summarize what we've done so far, we started a problem that we couldn't finish, but in order to finish this problem, we had to start a whole new problem. Up here we're using the quotient rule. Down here we're using the product rule. So now we've figured out what the derivative of x e to the x is using the product rule. It's e to the x times 1 plus x. And now that we know these four pieces, we can put those all back together to figure out our final answer, what this derivative is equal to. And so let's see, if we go back to our quotient rule, which we have written over here, the derivative of this divided by this is the derivative of the top, f prime, which we have written here is e to the x times 1 plus x, times g, got that written as 1 plus x, minus g prime, which is just 1, kind of nice, f is just x e to the x, and that whole thing gets divided by g squared. G is 1 plus x, so we'll divide by 1 plus x squared. So this right here is our answer. This is the derivative that we were looking for. A little bit complicated. We had to do 2 steps to get to it, but we got there. You could simplify this guy a little bit. We got 1 plus x and 1 plus x. So we can call that e to the x times 1 plus x squared minus x e to the x over 1 plus x squared. Word of caution, a very common mistake is for people to try to cancel out this 1 plus x squared and this 1 plus x squared. You cannot do that in this form. You can only cancel over multiplication. So we'd have to factor out a 1 plus x squared from both terms in the numerator. And this term over here doesn't have a 1 plus x squared. So there are different ways you could try to simplify this. Maybe you factor out an e to the x from both terms up top, and you could expand this out. But I don't know that any of the forms are really that much simpler than this guy. So maybe we'll stop here and call this guy our answer. So there's an example where to find a derivative, you have to use two separate rules at once, one rule inside another rule.